Welcome to A-Level and AP Physics. In today's lesson, we will discuss May June 2021 Paper 2-1 for Cambridge AS Physics exam. In today's class, we are talking about May June 2021 and total time for this exam is 1 hour and 15 minutes. And total mark for this paper is 60. On the second page of your exam paper, some constants and the values are given. And these are very important because you will need them for some calculations in your exam. If you remember them, it's wonderful. If you can't remember them, you can simply come back to second page and you can find the values. Let me highlight the constants you need for AS Physics exam. The first one is speed of light in free space, or speed of light in air, or speed of light in vacuum. Its value is given, so this is C. Its value is given. In exam, sometimes they will ask you to calculate frequency of electromagnetic waves. Only wavelength will be given to you. So you can use F is equal to V over lambda, and the value of the V is equal to C, because all electromagnetic waves, they have the same speed in air, same speed in vacuum, and their speed is equal to 3.0 times 10 to 8 meters per second. So this is very important for AS Physics. And the second constant you need is for AS Physics exam is elementary charge. Its value is equal to 1.60 times 10 to negative 19 coulombs, and this is equal to the charge on single proton and charge on single electron in magnitude. But the sign of charge for electron is negative and the sign of charge for proton is positive, but the magnitude is the same. So very important, you will need this one for AS Physics exam. Sometimes you will also need atomic mass units, so you need to understand 1U is equal to 1.66 times 10 to negative 27 kg. Rest mass of electron means the mass of electron. Mass of electron is equal to 9.11 times 10 to negative 31 kg. This is also important, you will need for some calculations at ES level. Next one is rest mass of proton, simply mass of proton when proton is not moving, or if proton is moving at low speeds is also the mass of proton. Simply at AS level you can understand this is mass of proton because we are not talking about relativity, so this is simply mass of proton. It is also important to remember acceleration of free fall. In your calculations, G you have to use 9.81, not 10 meters per second, so very important. So these constants you need for your AS Physics. So these are total 6. It's better to remember them. If you can't remember them, simply come back to second page and you can find the values here. On the next page, some important formulae are given. Let me highlight the formulae you need for AS Physics. The first one is for uniform acceleration, and this one you can only use when the acceleration of the object or body is uniform. Uniform simply means that if the acceleration is constant, then you can use these formulae. The next one you need for AS Physics is work done on gas or work done by gas, and this is W is equal to P times delta V. In this case, P is constant and delta V is the change in volume. If P is constant, then you can use this one. The next one you need for AS Physics is hydrostatic pressure, and P is equal to rho GH. Rho is the density of the fluid. The next one you need for AS Physics will be Doppler effect, and this is when the source is moving and observer is at rest. This is observed frequency and this is the frequency of the source, and V is the speed of sound in air. This V is also speed of sound in air, and Vs, this is the speed of source. You also need to understand when to use positive sign. Positive sign you will use when the source is moving away. So let me write down here when to use positive sign. Moving away. If the source is moving away, you will use positive sign. If the source is approaching, then you have to use negative sign. When the source is approaching observer, you have to use negative sign. So this is how you need to use this form. Next one is about electric current, and this is very important one because most of the time in exam they will ask you about how to use this one to calculate different variables. I here is equal to A, and A is the cross-sectional area, N is the number density of free electrons, or number of free electrons per unit volume, V is the drift velocity of free electrons, and Q is the charge on single electron, or simply you can say Q is the charge on single charge carriers. And the value of Q, this is equal to elementary charge, and that is simply equal to 1.6 times 10 to negative 19 coulombs. So you can see in this case Q is constant, N is constant if the material is the same. So N depends on material. So very important one. If the material means the wire is made of the same material, N will be the same. So very important point. Next one is about resistors in series. Very basic formula. Simply you need to add resistance of all the resistors if they are connected in series. Then the last one is about resistors in parallel. If the resistors are connected in parallel, this is how you can calculate the resultant, means the total resistance of resistors in parallel. That if all the resistors, they are identical resistor, means identical, they are the same resistors, then you can use one simple trick. For example, if there are 10 resistors, they are connected in parallel and they are identical resistors, then the total resistance simply is equal to the resistance of one resistor divided by the number of resistors. If resistors, they are identical and they are connected in parallel. So this is very important to understand these formulae, and the rest of the formulae you need to remember for your exam. For question number 1, part A, we need to define density. Very simple question. Density, simply you can define mass per unit volume. If you write down mass per unit volume, you will get 1 mark. And the mark for that one is B mark. Simply you need to write down mass per unit volume. So if you write down this much, you will get 1 mark. And that mark for this question is B mark, means it has to be in your answer. For part B1, we need to calculate the absolute uncertainty in X. But in the question, it is given to us the percentage uncertainty in X is given, that is plus minus 5%. So in order to calculate absolute uncertainty in X, simply we can write down in fractional form delta X by X. So this percentage uncertainty we can also convert into fraction, means simply you need to divide 5 by 100. Now you need to find out delta X. So simply we can say delta X, this is equal to 5 by 100 times X. Value of X is given, that is equal to 4 centimeters. So simply we need to multiply 4 with 5 by 100. If you simply multiply this one, our final answer will be 0.2 centimeters, because 4 is in centimeters. So final answer you can write down plus minus 0.2 centimeters, and this is the absolute uncertainty in X. So in your answer, simply you can write down 0.2. Plus minus, if you write, that is good. If you forgot to write, that is also okay for the sake of this question. If you have written 0.1, you will get 1 mark, and that mark is B mark. For part B2, we need to calculate the percentage uncertainty in the calculated value of rho. In order to calculate uncertainty, means the percentage uncertainty in rho, we need to rearrange first of all. If we rearrange this one, we can simply write down rho is equal to 3m divided by hx square. Now if we look at these quantities on the right side, we can see these quantities are multiplied and divided. So in order to calculate the percentage uncertainty in rho, simply we need to add the percentage uncertainties in the quantities on the right side. 3 is a number, so it has no uncertainty. So simply what we need to do is we need to add the percentage uncertainty in M plus the percentage uncertainty in H plus the percentage uncertainty in X. Percentage uncertainty in X. But X has exponent, it has power, so we need to multiply this one by its power, and that's all what we need to do. If you look at percentage uncertainty as it is given in this table is equal to 2%. So this is 2%. Percentage uncertainty in H is given, that is 4%. And percentage uncertainty in X, this is 5%, we need to multiply this one by 2. So the total percentage uncertainty in rho, that will be equal to 16. So that will be equal to 16% plus minus. So our final answer is plus minus 16%. This question has 2 marks, and the first mark will be awarded if you have written these percentages and you have added them, and that mark is C mark, means this is for your working if you have done the right working. And the second mark is answer mark. You will get the second mark if you have got the right answer. But if you have got the right answer but you haven't written these steps, still you will get full marks. For part C, we need to use data from table 1.1, and this is table 1.1. We need to calculate average pressure of the pyramid on the surface of the bench. Uncertainty is not required in our answer as it is given here. First thing, we need to understand how to calculate pressure. Pressure is simply equal to force over area in contact. Force in this case is equal to the weight of the pyramid, and that is the force exerted by pyramid on the bench. Simply we can write down force is equal to mg, and A is the area in contact. Mass of pyramid is given in this table, that is equal to 19.5 grams. We need to convert into SI units, means we need to convert into kilograms. Value of G at AS level you need to use is 9.81. Area in contact, so this is the area in contact with table, and that area is equal to x by x. That value of x is given, that is 4 centimeters. So simply we can write down 4 times 10 to negative 2 multiplied by 4 times 10 to negative 2. Now if we solve this one, our final answer will be 120 Pascal, and that's the final answer. So our final answer is 120 Pascal. For this question, let me explain to you how marks will be awarded. The first mark is for writing this formula. If you have written this right equation, you will get 1 mark. And the second mark is for substituting these values. You will get the second mark, and that is also C mark. And the last mark is answer mark. If you have got the right answer, you will get this mark. But if you have got right answer, you haven't written these steps, but still you will be compensated. You will get full 3 marks for this part. But if you got wrong answer and you have written these steps, means you have done the first step and the second step, you will still get 2 marks, even your answer is wrong. Welcome to A-Level and AP Physics. In today's lesson, we will discuss a typical type of question on kinematics and dynamics from May June 2021, Paper 2, Variant 1. For Part A1, we need to calculate the power required to overcome the total resistive force on the trolley and suitcases when they move at a constant speed of 1.4 meters per second. Power required we need to calculate. To overcome the resistive forces, it simply means that power required in this case will be equal to power dissipated due to resistive forces. Power dissipated. So power required is equal to power dissipated. Power dissipated simply we can calculate if we have the resistive forces and the speed of the trolley. For this case, it is given to us there is a constant total resistive force of 80 Newton and the speed of the trolley is also constant. If the speed is constant and force is constant, simply we can calculate power. Power will be equal to force times speed. In this case, force is equal to 18 Newton. We can write down this formula again here. This is only true if the force is constant and speed is constant. Here it is given to us F is equal to 18 Newtons and it is constant, and the speed of the trolley is also constant. Now if we simply multiply this one, our final answer will be equal to 25 volts. And this question has 2 marks. The first mark is if you have written this formula. And this is C mark. You will get first mark. And the second mark is answer mark. If you got the right answer, you will get the second mark. For part 2, we need to calculate the time taken for the trolley to come to rest after it is released. For this question, it is given to us the total mass of the trolley and the suitcases is equal to 72 kgs. It is also given to us there is a constant resistive force that is acting on this trolley. And the magnitude of constant resistive force is given that is equal to 18 Newton. And the trolley is moving to the right and the initial velocity of the trolley is given that is equal to 1.4 meters per second. It is also given to us this trolley finally comes to rest, means finally stop. So the final velocity of this trolley is equal to 0. Question is asking us we need to find the time taken between these 2 points. We need to find out the time taken between these 2 points. So this is what we need to find out. Time taken between these 2 points. As this resistive force is constant, so it means trolley has constant deceleration. So we can write down trolley has constant deceleration because a resistive force acting on this trolley is constant and this is the only force acting on the trolley. So the acceleration, or you can say deceleration in this case, that is also constant. If deceleration is constant, so we can simply calculate by A is equal to F net over m. F net over m. F net in this case is equal to Fr because there is only one force is acting on this trolley and that is resistive force divided by mass of the system. Fr is given, this is equal to 18 newtons and the mass of the trolley and suitcases is given, that is equal to 72. If we solve this, we will get value of A that is equal to 0.25 meters per second. As in this case, acceleration is constant, means deceleration is constant. So simply we can use kinematic equations. V is equal to U plus AT. We need to find out time. So simply we can rearrange this one. This is V minus U over A. For this part, V is equal to 0. So simply we need to plug in these values and U is given that is equal to 1.4. We need to divide by A. A is deceleration, means if we take to the right is positive, so AU is positive, but A is to the left. So this is direction of deceleration. So this is to the left. So this is also negative. So this is 0.25, but this is negative. So if we solve this, then our final answer will be 5.6 second, and this is the final answer. This question has 3 marks. So the first mark is if you have written this formula, A is equal to F net over M. The second mark is if you have done this calculation. And the third mark is the answer mark if you have got right answer. For part B1, we need to find the speed of the trolley at point Y. Means at this point, we need to find out what is speed of this trolley. It is given to us the speed of the trolley at point X is equal to 0 because it is given to us trolley was at rest at point X. And the displacement between point X and Y is also given that is equal to 9.5. Question is also telling us the component F of the weight of the trolley and suitcases that acts along the slope is equal to 54 newtons. We can also assume that constant total resistive force of 18 newtons opposes the motion of the trolley and suitcases. And this is the resistive force that is opposing the motion of the trolley. We need to find out V. Now this question is quite straightforward one. First of all, we need to calculate acceleration of the system, that will be equal to F net divided by mass of the system. F net in this case will be equal to 54 minus 18 divided by total mass of the system, that is equal to 72. If we solve this one, 54 minus 18, that will be equal to 36 divided by 72, and this will be equal to 0.5 meters per second. And this acceleration is constant. So simply we can write down this is constant. As this acceleration is constant, simply we can use 2as is equal to v square minus u square, means constant acceleration. So we can use these kinematic equations. From here, u is equal to 0. So simply this is given to us, this is equal to 0. We can write down from here v square is equal to 2as, or we can simply say that v will be equal to root of 2as. So simply this is v. Now we need to plug in values. A is given, that is 0.5, and s is equal to 9.5, and simply we need to take the root of this. If we take the root of this, that will be equal to 3.1, and this is the final answer. So the final answer is 3.1. This question has 3 marks. The first mark is if we have got the right value of acceleration. So this is first C mark. And the second C mark is if we have used this formula and we have plugged in these values. And the last mark is for answer if we have got the right answer. For part B2, we need to calculate the work done by F for the movement of the trolley from X to Y. We need to calculate work done by this force. The force and displacement, they are in the same direction, so we no need to worry about angle. We need to calculate work done by F, so we no need to worry about other forces as well. So we only need to consider F. We can simply say that W in this case will be equal to Ft, and value of F is given, that is equal to 54 newtons, and the displacement in direction of force is also given, that is equal to 9.5 meters. Now simply we need to multiply this one. If we multiply this, our final answer will be 510 joules, and that's the final answer. This question has only 1 mark, and that is answer mark. If you have got right answer, you will get this mark. For this part on figure 2.2, we need to sketch a graph between time t and the work done by force F when the trolley moves from point X to point Y. Numerical values of the work done and time are not required. It simply means we need to sketch. As the trolley moves from point X to point Y, there is resultant force acting on the trolley, and this trolley will accelerate, and acceleration will be constant. So this is direction of acceleration. Question is asking us, we need to find the relationship between work done and time. In this case, F is constant, meaning the magnitude of this force is not changing, but the displacement is increasing with time, and displacement is equal to ut plus 1/2 a t squared. This trolley started from rest, so the u is equal to 0. So simply we can say this term will be equal to 0. Then we can write down d is equal to 1/2 a t squared. Now simply we can replace d here with 1/2 a t square. If we look at this one, a is constant, 1/2 is constant, f is constant. So simply we can write down 1/2 fa. This is constant times t square. W is equal to this. These quantities are constant, so simply we can replace them with one constant. We can write down this is k times t square. So if we look at this equation now, this is equation of parabola. So simply we can write down this is equation of parabola. So the shape of the graph will be somewhat like this. It has to be curved, and its gradient has to increase. So it is curve. First thing, if you show it is a curve, you will get 1 mark, and that is M mark, means it must be a curve. And the second mark you will get if you show that the gradient of this curve is increasing. For part C, it is given to us the angle of slope in B is constant. The frictional forces acting on the wheels of the moving trolley are also constant. We need to explain why in practice it is incorrect to assume that the total resistive force opposing the motion of the trolley and suitcases is constant as the trolley moves between X and Y. Question is simply asking us why it is not correct to assume that total resistive force is constant, means total resistive force is not constant. We have assumed in the previous part that total resistive force is constant, but in fact total resistive force is not constant. So we need to explain now why total resistive force is not constant. Total resistive force, simply we can write down total resistive force. Total FR, total resistive force, this is equal to friction plus A resistance. Friction and A resistance. So this is equal to these two forces. Total resistive force. Friction is constant. It is given to us. Frictional forces are constant. So this force is constant. But A resistance, this depends on speed, and when the trolley is moving down the slope, means when it is moving between x and y, it is accelerating, so the speed is not constant, so speed is increasing. As speed is increasing, a resistance is also increasing, so total resistive force is not constant, it is increasing as trolley moves between x and y. So that's the reason we cannot assume that total resistive force is constant. If we assume total resistive force is constant between x and y, that is wrong, because a resistance increases with speed. So that's all what we need to write down. We can simply say a resistance increases with speed. So simply we can say that a resistance increases with speed. This question has only 1 mark. If you have written this, you will get 1 mark, and this is B mark. It has to be in your answer. Welcome to A-Level and AP Physics. In today's lesson, we will discuss one very important and typical type of question on mechanics from May June 2021 paper 2-1. I said it is important because in this question we will apply concepts of moment, forces, energy and momentum together. So it's a great combination of all these concepts and very important question to improve your understanding of mechanics. For this question, it is given to us a pendulum consists of a solid sphere suspended by a string from a fixed point P as shown in figure 3.1. It is also given to us the string has fixed length and negligible weight, means we can ignore the mass of the string. A resistance is also negligible. For part A on figure 3.1, we need to draw a solid line to represent the displacement of the center of the sphere at position y from position x. First of all, it is given to us the center of the sphere is at this point. Then center of sphere is at this point. Now we need to find the displacement. Displacement is the shortest distance between initial and final position. So this one is our initial and this is final. So if you want to write down, you can say that this is the initial position of sphere and this one is the final. So simply we can say this one is final position. So this one is final. Now we need to find the displacement. So displacement is simply is the shortest distance between these 2 points. So simply we need to connect these 2 points by a solid line. So this is how you can draw the solid line. For part B, we need to show that mass of the sphere is 0.30 kg. But for this question, momentum of the sphere is given and kinetic energy is also given in the previous part. If you read question, kinetic energy is also given. And kinetic energy is equal to 0.86 joules. Means kinetic energy at point X is also given. Now we need to find out what is the mass of the sphere. The question is that how we can link kinetic energy and momentum. If we can link kinetic energy and momentum, then it is quite easy to find the mass of the sphere. First of all, let's try to link momentum and kinetic energy. Kinetic energy is simply this is equal to 1/2 mv square, and if we multiply kinetic energy with m and we divide by m, so simply it means we are just multiplying by 1. Then we can simplify this. Now if you look at this now, so we have mm, so we can write down this will be m square and this will be v square and divided by m. But if you look at this one, m square v square, we can write down p is equal to mv. So if we have m square v square, we can say this is mv square. So this is momentum, means the square of momentum. So this is one small point you need to understand. Now, if we write down this equation in terms of momentum, we can say this is p square divided by m. Simply we can say kinetic energy is equal to p square divided by 2m. So it simply means that we can say that kinetic energy is equal to p square divided by 2m. For this question, we need to find mass, so we can rearrange this. We can write down this is p square divided by 2ke, means kinetic energy. Momentum is given to us. The value of momentum is 0.72. Square of this divided by 2 times kinetic energy, and that is equal to 0.86. Now simply we need to calculate. If we solve this one using calculator, our final answer will be 0.30 kg up to 2 SF, and this is our final answer. This question has 3 marks, and the first mark is if you have written this equation, this relationship, and second one if you have plug in values, this is second mark. This is actually C mark, this is also C mark, and the last one is answer mark, so this is A mark. So if you have done these steps, you will get these 3 marks. For part C, we need to calculate height h, means we need to find out value of this small h. For this question, it is given to us the kinetic energy at point x, this is equal to 0.86, and when the ball reaches at point y, the speed of the ball is equal to 0. It simply means that kinetic energy at this point, this is equal to 0. We can take this reference line where we can assume that the gravitational potential energy is equal to 0. But it is also given to us for this question, there is no air resistance. It simply means that in this case, mechanical energy is conserved. Means the initial mechanical energy is equal to final mechanical energy. So simply by using conservation of mechanical energy, we can write down kinetic energy initial plus gravitational potential energy initial. This has to be equal to kinetic energy final plus gravitational potential energy final. Kinetic energy initial is given, that is 0.86, and GPE initial is equal to 0. KE final is equal to 0, and GPE final, we can say this is equal to mgh. So h is the height. Now we need to find out h. So h, simply we can say that this will be equal to 0.86 divided by mg. So this is 0.86, and the mass we have already found. The value of mass was 0.30 kg in part B, and value of g at AS level we have to use 9.81. Now if we do these calculations, our final answer will be 0.29 meters. So this is our final answer. This question has 2 marks, and the first mark is for writing the formula for gravitational potential energy. If you have written this step, you will get 1 mark. And the second mark is answer mark. If you have got the right answer, you will get 2 marks. For part D, we need to show that theta is 47 degrees, and theta is the angle of the string with vertical. So this is string is at this position. Now this is the string, and this is vertical, and theta is the angle between string and vertical. We need to find out its value. Length of the string is given. In the question, it is given to us. This is 0.93. So the length of the string, we can simply write down. This is 0.93 meters. Now, if we can complete right angle triangle, then it is very easy to calculate angle. So this is our right angle triangle, means this angle is 90 degrees. If we look at this angle, this is the angle with vertical. If we look at the angle of vertical with horizontal, this total angle will be 90 degrees. Theta is given, so this angle has to be 90 minus theta. This is right angle triangle, so the sum of these two angles has to be equal to 90, so this angle has to be theta. Now it is also given to us, we have calculated h that was equal to 0.29. So the length of this side of the triangle, this is 0.93 minus 0.29. Now we have the length of this side and we have the length of string. So simply we can say, in this case, cos of theta, this will be equal to 0.93 minus 0.29 divided by the length of the string. This is 0.93. We can also construct this triangle again. Now we can simply construct this triangle like this. In this case, this angle is the theta and this side is given to us. This is 0.93 minus 0.29 and this side is 0.93. We are simply calculating this angle now. If we solve this one for theta, our final answer will be 47 degrees, and this is our answer, and this is answer mark, so this is A mark. For part E, we need to calculate the moment of its weight about point P when the sphere is at position Y. Means when the sphere is at position Y, we need to calculate its moment about point P. We can approach this problem using two different methods, means two different approaches. The first approach can be, we can simply multiply force with perpendicular distance between line of action of the force and the pivot. So this can be one way to answer this problem. And the second way to answer this problem can be, we can resolve force into its components and we can multiply the perpendicular component of the force with the distance between pivot and point of action of the force. First of all, look at the first approach. So force we can take, in this case, the force acting at this point is simply equal to the weight of the sphere. So it is equal to weight of the sphere. We need to multiply this one with the perpendicular distance between line of action of force, this is line of action of force, and the pivot point. And that distance, this is the perpendicular, and this distance is simply equal to, if we construct this triangle, you can simply understand this one. This is the angle theta. We have calculated this angle theta is 47 degrees, mean this angle, and this side is given, this is 0.93, this is length of the string. Now we need to find this side. So this is simply equal to 0.93 sine of 47 degrees. So if we multiply these two, we can find moment. So this is mg. We need to multiply this one with 0.93 sine of 47 degrees, and we can calculate the value of moment. M in this case is given, that is 0.93, and the G we need to use is 9.81. We need to multiply this one with 0.93 sine of 47 degrees. So this is sine of 47. If we solve this, our final answer will be 2.0 Newton meters. This is how we can approach. And the second way to answer this one, we can resolve this weight into its components. So we can resolve into two components. So these are two components. There is no moment due to this component because this is passing through. Line of action of this component is passing through the pivot. So there is no perpendicular distance. So there is no moment due to this one. There is moment only due to this component. First is only due to this component. We need to find out this angle. Alternate angles are equal. So this angle is also theta. I mean this angle is 47 degrees. Now if this angle is 47 and this component will be mg sine of 47 degrees. So this perpendicular component is mg sine of 47 degrees. So F perpendicular is mg sine of 47 degrees, and the distance between point of action of the force and pivot is 0.93. So we can say this is 0.93. Now you can see these two are the same. So simply if we solve this, our final answer also will be equal to 2.0 Newton meter. So this is the answer. So we have two approaches. You can resolve distance into its components, or you can resolve force into its components. Your answer will be the same. But sometimes one approach is easier than the other one based on the given data and based on the given situation. This question has 2 marks, and the first mark is if you have written this relationship, you will get 1 mark, and this is C mark. And the second mark is answer mark. If you have got the right answer, you will get 2 marks. For our next part, we need to state and explain whether the sphere is in equilibrium when it is stationary at position Y. And this is the confusing point. They have given you when it is stationary, and often students they get confused with this point. And this question is very similar to this one. When the ball is at the highest point, the speed of the ball is 0 at this point, but still there is a gravity that is acting on this ball, that is mg. So the acceleration of this ball is still a is equal to g even when the ball is at the highest point. So this question is similar to this one based on this understanding. Now when the sphere is here, it is at rest, it is stationary, but at the same time its direction of motion is changing. So there is a force acting on this one that will cause the change in its motion. So there is a force acting on the sphere at this point. So this is what you need to understand. Now let's try to look at the forces now. When the sphere is here, there is one force that is acting up, that is the tension in the string. And one is a component of the weight that is acting along this line, and these two are equal because sphere is not moving along this line. But the sphere will start moving this way, and so there is a force acting on the sphere, and this force is the component of the weight. So this is mg sine 47. So this is the component of the weight. So it simply means that there is resultant force when the sphere is stationary at position Y. So there is resultant force. It simply means that this is not in equilibrium. So first thing you can state, not in equilibrium. So this is one thing you have to state. Now you need to explain why. Simply you can say there is resultant force acting on sphere. You can say there is resultant force. So simply if you write down this one, why it is not in equilibrium? Because there is resultant force acting on sphere. You will get 1 mark for this question. This is how we can approach. So there is a resultant force because direction of motion is changing, and that resultant force is equal to the component of the weight. Welcome to A-Level and AP Physics. In today's lesson, we will discuss question number 4 from May June 2021, paper 2-1. This question is about waves, especially based on properties of waves and diffraction grating. These two concepts are very important because most of the time they will ask about these concepts in CAIE exam. For part A, we need to state what is meant by wavelength for progressive wave. First of all, let's try to understand what is progressive wave. Progressive wave is also called traveling wave because these waves transfer energy in direction of wave. So that's the reason we call them progressive waves. And examples of progressive waves are transverse waves and longitudinal waves. Let's try to understand what is meant by wavelength with the example of transverse wave. So this is an example of transverse wave. Now if we look at this transverse wave, we can take 2 points. Let's say we take this point and this point. Particles at these 2 points, they will always oscillate in phase. So simply we can say these 2 points on the wave, they are in phase, and the minimum distance between these 2 points is equal to 1 lambda, mean is equal to wavelength. We can also take any other 2 points which are in phase. Let's say if we take these 2 points, so the particles at these 2 points, they will always oscillate in phase. So the minimum distance between these 2 points, this is equal to 1 wavelength. We can also take any other 2 points. Let's let's say if we take this point on the wave and we take this point, so particles at these 2 points, they will also oscillate in phase. So the minimum distance between these 2 points is also equal to 1 lambda. This is how we can define wavelength. This is how you can write down your proper answer for this question. So let me highlight some points. When you define wavelength by saying the distance between two wavefronts, you must say minimum distance, because this is the minimum distance between two wavefronts, or we can say between two crests. We can also say the minimum distance between two crests. We can also say the minimum distance between two troughs, or we can say between 2 points in phase on the wave. Another way to define wavelength is distance moved by wavefront during one cycle of source. It simply means that one cycle is completed by source, the distance traveled by the wave, that will be equal to one wavelength. So this is another way to define wavelength. For part D, it is given to us a light wave from a laser has a wavelength of 460 nanometers in vacuum. We need to calculate the period of the wave. First thing we need to understand is a light wave. So light waves are electromagnetic waves. So simply we can say light wave is electromagnetic wave. Now it is given to us, the medium is given. Medium is vacuum, and in vacuum or in air, the speed of electromagnetic waves, this is equal to speed of light, and the magnitude is equal to 3.0 times 10 to 8 meters per second. Means all electromagnetic waves, the speed is the same in vacuum, or we can say the speed is approximately same in air. So V is equal to 3.0 times 10 to 8 meters per second, and this is the speed of all electromagnetic waves in vacuum. Now we have speed and we have lambda. So we can simply say V is equal to lambda times F. F is the frequency, and the frequency is equal to 1 over T. So simply we can say V is equal to lambda over T, or simply you can say multiplied with 1 over T. And from here we can rearrange. So the T time period, this will be equal to lambda over V. Lambda is given to us, and this is equal to 460 nanometers. It simply means 10 to negative 9 divided by the speed of light. So 3 times 10 to 8. Now if we simply solve this, our final answer will be 1.5 times 10 to negative 15 seconds, and this is our final answer. So this is simply we can write down, this is our final answer. This question has 3 marks. The first mark is if you have written this expression, you will get first C mark. And the second C mark is if we have written, means we have plugged in these values. And the last mark is answer mark, and this is A1. So this is final answer mark. If your answer is right, you will get full marks. For part C, it is given to us the light from the laser is incident normally on a diffraction grating. We need to describe the diffraction of the light waves at the grating. So here is diffraction grating. So this one is diffraction grating. In this diffraction grating, you can see small holes, and these holes we call them slits. So these are slits. If you look at light waves, when they pass through this slit, these light waves, they spread out, and this spreading out of light waves as they pass through slits is called diffraction. So simply we need to say that waves spread out as they pass through the slit, and that is diffraction. Let me show you how you can write a proper answer for this question. So this is how you need to write down your answer. If you have mentioned in your answer waves spread out, you will get 1 mark, and this is B mark, means it has to be in your answer. And the second mark you will get if you have mentioned as they pass through the slits, so you will get second B mark. So this question has 2 marks. If you have mentioned waves spread out, you will get 1 mark. The second mark, if you have mentioned as they pass through the slits, you will get second mark. So total marks for this question are 2 marks. Geometric shadow. Maybe some of you are a little curious about that. What is meant by geometric shadow? Geometric shadow means that if these waves, they don't spread, you will not see the light here. So there will be shadow, means no light here. But in this case, when the light pass through the slit, it's spread out. So waves spread into geometric shadows. It means they will illuminate these regions, and these regions are the geometric shadows. For part D, it is given to us a diffraction grating is used with different wavelengths of visible light. The angle theta of the fourth order maximum is measured for each wavelength, as you can see in this figure 4.1. On y-axis, sine theta is plotted, and on x-axis, lambda is plotted. It is also given to us the gradient of this graph. This is equal to g. So from here, simply we can write down the g. This is equal to sine of theta divided by lambda. So this is the gradient. We need to determine an expression in terms of capital G for the distance d. So first you can start from here. For diffraction grating, we simply understand d sine of theta. This is equal to n lambda. We need to find d. So simply we can write down d is equal to n lambda over sine of theta. If we look at g, this is equal to sine theta over lambda. If we write down 1 over g, this will be equal to lambda over sine theta. Now we can simply replace lambda over sine theta with 1 over g. So this is 1 over g. In this question, it is given to us for fourth order maximum. Fourth order means 4, n is equal to 4, and this is divided by g. So d simply is equal to 4 over g, and this is our answer for this question. We can say d is equal to 4 over g. This question has 2 marks. The first mark you will get if you have written this equation. So you will get first mark, and this one is C1 mark. And the final mark is answer mark. So this is answer mark. For second part on figure 4.1, we need to sketch a graph to show the results that would be obtained for the second order maximum. So this is quite straightforward question. If we look at our previous result, we have found d is equal to n over capital G. For the fourth order, d was equal to 4 over capital G. Now from here, if we rearrange, we can find g. So g will be equal to 4 divided by d. Now question is asking us for second order. So we can write down g for the second order. This will be equal to 2 divided by d. But in this case, we are using the same diffraction grating. So it means d is the same. So d is the same, mean the slit separation is the same for the same diffraction grating. If this become half, now this become half if we compare with 4. So this decreases, this become half. So it means g also become half. Next thing we need to understand, g is equal to the change in y divided by the change in x. So if we draw the line from here to here, delta x is the same. Change in delta x is the same. So if g become half, it means delta y has to be half. So based on this, we can draw the line. So the best way to draw this one is, first we can look at this. So this is about 1, 2, 3, 4, 5 units. So we can take the half of that. So this is about 2.5 units here. And this is 10. So we can take the 5. So this is 1, 2, 3, 4, 5. So 5 units here. And then we simply need to connect. So in this case, delta y will be half, but delta x will be the same. So let me show you how you can draw a proper line. So this is how you need to draw the proper line. So this is how you can draw the proper line. You can see this is about 2.5 here. So this is about 2.5 units, and this is about 5 units. So you can see 1, 2, 3, 4, 5. So this is 5 units. So the gradient of this red line is half, and this question has 2 marks. So if you have drawn in a proper way, you will get 2 marks. So the first mark is for the straight line. If you have drawn the straight line from 400 nanometers to 700 nanometers, you will get 1 mark. If the gradient of this line is smaller than the gradient of previous line, you will get the second mark. Welcome to A-Level and AP Physics. In today's lesson, we will discuss a typical type of question on electricity from May-June 2021, paper 2-1. For part A, we need to state Kirchhoff's second law. Kirchhoff's second law simply tells us sum of EMFs. EMFs means if we have more than one electrical source in the circuit, that has to be equal to sum of potential difference, or simply we can say sum of TDs in a closed circuit. So we also need to mention in a closed circuit, we can say in a closed circuit, or we can say in a closed loop. In a closed circuit, or you can also say in a loop. Now this question has 2 marks. The first mark is for this part. If you have written sum of EMFs is equal to sum of PDs, you will get 1 mark. And this is M mark, means it must be in the answer. And the second mark is answer mark. So this is second mark. But if you cannot get M mark, you will also not get A mark. So M mark is must mark, means it must be in your answer. And the A mark is depending on M mark. If you can't get M mark, you will also lose A mark. Let's try to understand Kirchhoff's second law with the help of one simple circuit. So let me draw one circuit here first of all. If you look at this one very simple circuit, let's say the EMF of this cell is E and this resistor is R1. If we connect voltmeter across this one, let's say the reading on this voltmeter is V1. And this is the potential difference across this resistor. And now if we look at this closed loop, in this case simply we can say the EMF is equal to the potential difference across the resistor. So this is our closed loop. So simply we can say in a closed loop, in this case, in a closed loop, or we can say in a closed circuit, EMF is equal to V1. Means the EMF is equal to potential difference. We can also extend this idea to 2 resistors. Now let's connect 2 resistors across this cell. So this is our resistor 1, and here let's say we have another resistor. We can say this is R2 and this is R3. If we connect voltmeters across these resistors, and let's say the reading on this voltmeter is V2, and this is telling us the potential difference across second resistor. And we connect another voltmeter, and that one is across third resistor. Now if you look at this closed loop, means if we start from here and we form a closed loop. So this is our closed loop. Now if you look at this closed loop, we can also say that in this case EMF is equal to V1 plus V2. If we have more than one power source, then we will say E1 plus E2. Let's say we have 2 power sources. In this case, I can also connect another source here. Let's say this is another cell that is connected here. So this is E1 and this is E2. And so the EMF of this cell and the second cell, we will say in this case V1 plus V2. So simply we can say the sum of EMFs in any closed loop, sum of EMF is equal to sum of PDs, and this is Kirchhoff's set, and this is how you need to state. For part B, it is given to us the wire XY, means this wire XY. The resistance of this wire is given. Simply we can say the resistance of this wire is 0.90 ohm. So this is resistance of this wire. It is also given to us the potential difference across XY. This is equal to 1.8 volts. This simply means if we connect voltmeter across this wire, means between X and Y, the reading on this voltmeter, this is equal to 1.8 volts. Now question is asking us, we need to find out how much current is passing through this wire. So very straightforward one. Simply we need to use Ohm's law. We will say V is equal to IR. V is the potential difference across the wire. So simply by using Ohm's law, we can find I. From here we can say I will be equal to V over R. V is the potential difference across the wire. R is the resistance of the wire. So the potential difference across wire is 1.8 volts. We need to divide by the resistance of the wire, that is 0.90 ohms. So our final answer in this case will be 2.0 amps. And this is the final answer. This question has only 1 mark. If you have got the right answer, you will get this 1 mark. So simply we can say up to 2 SF, this is 2.0 amps. For part D, we need to calculate the number of free electrons that pass a point in the battery in a time of 45 seconds. First thing we need to understand, the current leaving this battery is I and current entering this battery is also I. And value of I we have already calculated, that was equal to 2.0 amps. Time is given to us, time in this case is equal to 45 seconds. So T is equal to 45 seconds. We need to find out number of electrons. So we can start from here. Q is equal to IT. But we need to find the number of electrons. So Q we can write down. Q will be equal to N times E. N is the number of free electrons and E is the charge on single electron. So we can say NE, this is equal to IT. We need to find out value of N. So simply we can rearrange. We can say N is equal to IT divided by E, and E is the charge on single electron. I is given to us, this is equal to 2, and the time is given, this is 45 seconds. And the charge on single electron is 1.6 times 10 to negative 19 coulombs. If we simplify this one, our final answer will be 5.6 times 10 to 20. And this is the number of electrons. And this is the number of electrons passing through a point in 45 seconds. So our final answer is 5.6 times 10 to 20. This question has 2 marks. The first mark is if we have written Q is equal to IT. So this is C mark. We will get 1 mark. And the second mark is answer mark. And this is for the right answer. If you have got right answer, you will get 2 marks. For this part, we need to calculate the resistance of capital R. Simply, we need to find what is value of this capital R. For this purpose, we simply need to use Kirchhoff's second law. According to Kirchhoff's second law, in any closed loop, as we have discussed in part A, in any closed loop or circuit, sum of EMFs simply we can say sum of EMFs has to be equal to sum of PDs, potential difference. If we look at this closed loop now, we can first draw this loop. This is just one loop, so let's redraw this one loop. In this loop, we only see one EMF, and that is 4.0 volts. Now, if we go across this wire, for this wire, potential difference across this wire is given in the question, and the value of that is 1.8 volts. And so we can simply write down here, or we can simply say VXY, potential difference across this wire, plus the potential difference across capital R resistor, and we can say this resistor is small r because this is internal resistance. We can denote this one with small r. So this is I times R. Now simply we need to plug in values. So we have 4.0 and VXY, it is given in the question, and that is equal to 1.8 volts. I in the question we have, this is 2 amps and this is the capital R, the resistance. I also the same passing through this internal resistance, so this is also 2. And the value of R we have, that is 0.35 ohms. Now if we simplify for R, our final answer for R will be 0.75 ohms, and this is our final answer. So this is 0.75 ohms. And the first mark you will get if you have written this one. So this mark will be C1. And the second mark you will get if you have got the right answer. Simply speaking, if you got the right answer, you will get 2 marks for this question. For part C, we need to calculate total length L of wire XY. But for this question, it is given to us the connection P is moved along the wire XY. It simply means that we started moving our slider from this point and we keep on moving this one until it is at point P. Now it is given to us the galvanometer reading is 0 when the distance xp is 0.30 meters. Means the distance between x and p when this is equal to 0.30 meter. The reading, if we connect voltmeter across xp, means between x and p, the reading on this voltmeter is equal to 1.20 volts because this galvanometer reading is equal to 0. So this is what question is telling us. What we need to do is we need to find the total length of wire xy. But in the previous part we have already calculated the potential difference across xy, means simply if we connect voltmeter between x and y, the reading on this voltmeter is 1.8 volts. We have already calculated in the previous part. In order to answer this question, you need to understand the ratio between Vxp and Vxy is equal to the ratio between Lxp and Lxy. But for this question, it is given to us that Lxy, this is equal to L. So simply we can say Lxy is equal to L. Now we need to find out value of L. So simply we can say in this case, L will be equal to Vxy multiplied with Lxp divided by Vxp. Vxy we have that is equal to 1.8 volts. We need to multiply with Lxp. Lxp is 0.30 meters. We need to divide by Vxp, and the Vxp is 1.2. So this is 1.2. If we solve this one, our final answer will be 0.45 meters. So this is the final answer. This question has 2 marks. The first mark is if you have written in this form, means if you have written the ratio between Vxp and Vxy and the ratio between Lxp and Lxy, these are equal, you will get 1 mark. So this is C mark. And the second mark is answer mark. This is for the answer. If you got right answer, you will get 2 marks. Let's try to understand a little bit more about potentiometer and especially about this relationship, I mean how we got this one. So let me explain you this part. Simply we can say that Vxp, this is equal to I times R. Here we are talking about Xp part of the wire. We can say current in that part and resistance of that part. We can also write down Vxp is equal to Ixp times the resistance. That we understand resistance is equal to resistance of any wire. This is equal to rho L by A. So we can write down here, this is rho and A is the cross-sectional area of the wire. We can say this is AXP. And we can simply write down VXP. In this case, this is equal to IXP times rho times LXP, and this is divided by AXP. So this is how we can write down VXP. We can also follow the same procedure for VXY. For VXY, we can say this is equal to IXY times resistance of wire XY. I is the current passing through wire XY. So we can write down this IXY. Resistance we can write down, this is resistivity times length of the wire XY divided by the cross-sectional area of the wire. So we can say this is AXY. So this is VXY. Now we need to understand for these two wires what is the same. For the same wire, now we can say for same wire, because in this question we are talking about this wire and this is the same wire. Simply this is the same wire. We are talking about this same wire, and for this same wire now we need to understand what is same for XP and for XY. The first thing we can say that in this case IXP, this will be equal to IXY, or simply we can say this is equal to I. Second, we need to understand AXY, because the same wire and the cross-sectional area of the wire is uniform. So we can say AXP, this will be equal to AXY y, or simply we can say this is equal to a. Rho is also the same because we are talking about the same wire, so it means rho xp, this is equal to rho xy, and we can simply say this is equal to rho. Now simply we need to divide, so we can write down vxp. If we divide vxp by vxy, we can also say this is equation 1 and this is second. So we can say 1 divided by 2 means equation 1 divided by 2. So we can write down these things here. So here we got I, and this is rho, and this is LXP. So this is LXP, and this is divided by A. AXP is equal to A. And we need to multiply this one with A divided by I times rho, and this is LXY. Now from here, simply we need to cancel. So you can see I is here. We can cancel with I. Rho we can cancel with rho. A we can cancel with A. So we left with Vxp over Vxy. This is equal to Lxp divided by Lxy. That's the reason we wrote ratio between Vxp and Vxy is equal to ratio between Lxp and Lxy. So this is how you can derive this one. So simply let me write down again here. So we will get Vxp divided by Vxy. This will be equal to Lxp divided by Lxy. Means the ratio between potential difference is equal to ratio between L. For the second part, it is given to us the fixed resistor is replaced by a different fixed resistor of resistance greater than capital R. We need to state and explain the change, if any, that must be made to the position of P on wire XY so that the galvanometer reading is again 0. We can divide this question into two parts. First thing we need to understand, when the resistance of this resistor is increased, what is the effect of this one on the potential difference between X and Y, means on the reading of this voltmeter. So if this resistance increase, the potential difference across XY, it will go down. So this is the first thing we need to understand. The potential difference across XY, this will go down. We also need to understand that the ratio between Vxp and Vxy, this is equal to Lxp by Lxy. From here we can write down Lxp, this will be equal to Vxp times Lxy, and this is divided by Vxy. But if you look at this question, it is given to us that Vxp is not changing. We want the same Vxp. Mean this one is not changing. Lxy, the length of the wire, this is also not changing. But Vxy has decreased. So if this has decreased, so Lxp has to increase. This is how you can write down your answer. So we have simply mentioned PD across XY decreases, as we have discussed here. PD across XY decreases. So if you have written this one, you will get 1 mark, and this is B1 mark, means it has to be in your answer. The second mark you will get if you have written P is move towards Y, mean this P you have to move to the Y, or simply you can say to the right. So you will get the second mark, and second mark is also B mark. It has to be in your answer. Welcome to A-Level and AP Physics. In today's lesson, we will discuss a typical type of question on standard model from May June 2021 paper 2-1. I said this is typical type of question because this type of questions are very common in past papers, and these type of questions have been asked many times in the past. For part A, it is given to us a proton in a nucleus decays to form a neutron and a beta plus particle. Beta plus particle in fact is positron. So this is antiparticle of electron, and this positron is a lepton. So we need to understand positron is a lepton. lepton. So this belongs to lepton family. For part 1, we need to state the name of an other lepton that is produced in the decay. In this case, beta plus particle is emitted. So this tells us this is beta plus decay. So let's try to understand, first of all, what is beta plus decay. If beta plus particle is emitted, it means this is beta plus decay. If electron is emitted, it means this is beta minus decay. So this is beta plus decay. Let's say we have one nucleus X. Atomic number of this one is Z, and this nucleus decays to an other nucleus by beta plus decay. So by beta plus decay. So this is our beta plus particle. So you can also write down it has charge plus 1 and it has mass number 0. So in this case, we can simply write down the Z. This will be Z minus 1 because this is plus 1, and this has to be A. Mass number will not change, and other particle is emitted. So beta plus particle, this is antiparticle. So in this case, electron neutrino will be emitted. So electron neutrino has no mass number and also no atomic number. So simply we can write down here. So this is electron neutrino. So the way to remember this one is, look at this particle. So if this is antiparticle, we can simply write down, if this is antiparticle, means if this is positron, that is antiparticle of electron. This one has to be particle, means this has to be neutrino. So this one has to be particle, and vice versa is also true. If this is particle, means if this is electron, this one has to be antiparticle, means electron anti-neutrino. So this is the point you need to understand, particle and antiparticle. This is due to lepton number, means the lepton number has to be conserved. That's the reason one has to be particle, other one has to be antiparticle. Because lepton has a lepton number plus 1 and anti-lepton has a lepton number of minus 1. So that's the reason one has to be particle, other one has to be antiparticle to conserve lepton number. So for the answer of this question, simply you need to write down electron neutrino. So we can write down electron neutrino. And this question has 1 mark, and that is B mark. So it has to be in your answer. If you only write down neutrino, still you will get 1 mark. But the proper way of writing is electron neutrino, because there are different types of neutrinos: electron neutrino, muon neutrinos, and tau neutrinos. So this is electron neutrino. So the proper way of writing is electron neutrino. But in order to get marks, if you only write down neutrino, still you will get 1 mark. For the second part, we need to state the name of interaction that gives rise to this decay. This is typical type of question, and for this one we need to understand when quark change from one flavor to another flavor, or simply we can say when quark change from one type to another type, or simply we can say when the down quark it change into up quark, or vice versa is also true. If up quark change into down quark or any other type of quark, when it change from one form to another form, the interaction, the force responsible for that is weak nuclear force. So simply answer for this question, you need to write down weak nuclear force. And weak nuclear force is also responsible for fusion process in the sun. So weak nuclear force, when quark change from one form to another form, force responsible is weak nuclear force. Nuclear fusion process is taking place in sun, so the force responsible for that nuclear fusion is also weak nuclear force, because when protons they combine together, they form helium nucleus, and in helium we also have neutron. So protons change into neutrons. So the quark is again means change from one form into another form, so weak nuclear force is also responsible for that. So this is what we need to understand. This question has only 1 mark, and that is B mark. So it has to be in the answer. This is what you need to write down. You can write down weak nuclear force, you can write down weak nuclear interaction. And this force, weak nuclear force, it has the shortest range, and the range of this force is about 10 to negative 18 meters. Even this range is shorter than strong nuclear force. Let's move on to next part. For the next part, question is asking us state which of the three particles, proton, neutron, and beta plus particle has the largest ratio of charge to mass. Simply is asking us Q by M. Which one has greatest ratio of Q by M? First of all, let's look at proton. For proton, the charge on proton 1.6 times 10 to negative 19 coulombs, and the mass of one proton is about 1.66 times 10 to negative 27 kg. So this is Q over M for proton. So we can say this is for proton. And for neutron, so we can write down here Q over M for neutron. Neutron has no charge, so this is 0. And the mass of neutron is about 1.67 times 10 to negative 27 kgs. We can also do the same for beta plus particle. For beta plus particle, the charge on beta plus particle is the same as the charge on single electron, or we can say as the charge on single proton. So this is 1.6 times 10 to negative 19 coulombs. So we can write on here. And the mass of beta plus particle, it is the same mass as mass of single electron, and the mass of single electron is 9.11 times 10 to negative 31 kgs. Now simply we need to compare them. So QM for neutron, this will be equal to 0 because there is no charge. But now we need to compare proton with beta plus. So you can see they have the same charge, but the mass of proton is greater than the mass of beta plus. So it means this number is small, but this is the same for proton, same for beta plus. So it means Q over M for beta plus is higher than Q over M for proton. So simply we can write down our answer is beta plus particle. So it has higher Q over M ratio. So the answer is beta plus particle. And this question has B1 mark, means that only one B mark, and this has to be in your answer. For the next part, we need to use the Quark model to show that the charge on the proton is plus E, where E is the elementary charge. First of all, let's try to understand what is Quark composition of proton. Proton consists of 2 up quarks and 1 down quark. The charge on 1 up quark is plus 2 by 3e, and the charge on 1 down quark, this is minus 1 over 3e. Now simply we need to add these charges together. So the charge on 1 up quark, this is 2 by 3e. We have 2 up quarks, so we can write down this 2 times, and we need to add the charge on down quark, and the charge on down quark is minus 1 over 3e. Now simply we can add these two. So plus 2 by 3e plus 2 by 3e. So simply we can say this is plus 4 by 3e minus we have 1 over 3e. Now simply we need to add, we can take LCM. So this will be 4 minus 1 times e. So if we simplify this one, our final answer will be plus e. So the charge on single proton is equal to plus e. This question has 2 marks, and the first is if we have written the quark composition for proton, we will get 1 mark, and this is B mark. I mean, it has to be in your answer. And the last one is, this is also B mark. If we have shown that our final answer means the charge on the proton is plus E, you will get the second mark. For part 5, we need to describe the change to the quark composition. But for this question, it is given to us proton changes to neutron. So simply we can write down, first of all, proton changes to neutron. So we can simply write down here, proton changes to neutron. Now we need to write down the change in quark composition. Proton consists of 2 up quarks, 1 down quark. But neutron, it consists of 1 up quark and 2 down quark. So this is the change, means 2 up quark and down quark changes into 1 up quark and 2 down quark. Simply we can say in this case, one up quark changes into one down quark. So that's all what you need to write down for this question. And this question has 1 mark. If you have written this one, you will get 1 mark. Means if you have written up down quark changes to up down quark, you will get this 1 mark. For part B, it is given to us a nucleus X, the proton number is 6, our atomic number is 6, and mass number is 12, and the nucleus Y. Mass number is 16 and proton number is 8, or we can simply say atomic number is 8, are accelerated by the same uniform electric field. We need to determine the ratio between the electric force acting on nucleus X and electric force acting on nucleus Y. First of all, let's try to understand what this is telling us. If you look at nucleus X, so it has atomic number 6 and the mass number is 12. So the charge on this one means the charge on X, this is equal to its atomic number. So simply we can say this is 6e plus, means 6 times the charge on single proton. Now if we look at nucleus Y, for nucleus Y, proton number is 8, meaning atomic number is 8, and the mass number is 16. So the charge on this particle is equal to 8 times the charge on single proton. These two, they are accelerated through the same electric field, and the field is uniform. Same uniform electric field. So we can place these two nuclei in this electric field. So we can assume we have nucleus X here, so it has atomic number 6, its mass number is 12. And we have another nucleus Y, its atomic number is 8, its mass number is 16. They are accelerated in this uniform electric field. So as it is uniform electric field, it means E is same everywhere in this field. We can simply say E is same. Now we need to find the ratio, so we can write down the ratio. This is the force on X divided by the force on Y. That the electric force is equal to E times Q, so we can say this is EQX and this will be EQY. E is the same, so we can simply cancel E with E, so we left with QX, and the QX we can write down, this is 6E plus 8E plus. Now if we simplify, so E plus we can cancel, so our final answer will be 0.75, and this is the final answer what we need to find out. This question has 2 marks. The first mark is if we have used this equation, so you will get C 1 mark. And the second mark is the answer mark. If you have got the right answer, you will get 2 marks for this question. For part 2, we need to determine the ratio between acceleration of nucleus X and acceleration of nucleus Y. So they are still in the same uniform electric field. So this is given to us. They are in the same uniform electric field. So let me redraw. So this is uniform electric field. This plate is negative plate, so this is negative plate, and one plate is positive. So the electric field between these two plates is uniform electric field, means value of E is same everywhere. So they are accelerated in this uniform electric field. So we can say this is nucleus X and this is nucleus Y. Now we need to find the ratio between their acceleration. So simply we can start from here. So the ratio you need to find between AX by AY, and acceleration is equal to force divided by mass. So this will be the force on X divided by mass of X, and we need to divide this one by acceleration of Y. So this will be the force on Y divided by the mass of Y. Now we can simplify this and we can write down this will be force on X times the mass of Y nucleus divided by, this will be the force on Y nucleus times the mass of nucleus X. We can further simplify. We can see that electric force is equal to EQ, so we can replace with F with E times QX, and here we have mass of Y, and same we can do for Y, Fy. F is equal to E times the charge on y times the mass of x. Now from here we can simply cancel E because E is the same. They are in the same uniform electric field, so we can cancel this. So we left with this is Qx divided by Qy, the ratio between these two, and times the ratio between mass of y and mass of x. Now we have already found the ratio between Qx and Qy, that was equal to 0.75. So simply we can write down 0.75. Now we need to find out the mass of y and the mass of x. Mass of y, this is equal to 16u. The mass of y, this is equal to 16u. But 1u is equal to 1.66 times 10 to negative 27 kgs. You don't need to write down in form of kgs, but if you want to write down, you can do that part as well. And the mass of x is 12u. So simply we can plug in these values here. So the mass of y is 16u and the mass of x is 12u. So simply u we can cancel, or you can plug in values in terms of kgs. You can write down, you can say this is 0.75. This is multiplied 16 times 1.6. If you're a little confused with u, so you can just write down in terms of kgs, and this is divided by 12 times 1.6 times 10 to negative 27 kgs. Now we can cancel out. So 1.6 times 10 to 27 we can cancel. So we left with 0.75. This is multiplied with 16 divided by 12. So if we solve this one, our final answer is going to be 1.0. And this is the ratio between acceleration of x and acceleration of y. This question has only 1 mark. If you got the right answer, you will get that mark. I have explained in detail, but because sometimes some students they are confused with little points, so I have explained you in detail so you have clear picture of this question. For this question, it is given to us nucleus X is at rest in the uniform electric field at time t is equal to 0. The field causes nucleus X to accelerate. On figure 6.1, we need to sketch the variation with time t of the acceleration a of nucleus X due to the field. First of all, let's try to understand uniform electric field. In uniform electric field, so let's say this plate is positive. We can simply imagine this plate is positive and this plate is negative. And the electric field between these two plates will be uniform electric field. As we have discussed before, E is the same everywhere in this field. So that's the reason we call this is uniform electric field. Now for this question, it is given to us a nucleus X is placed inside this one. Then this nucleus X has positive charge, so it will accelerate in this direction. Now we need to find out how A will change with time. If we look at this nucleus X and if we need to calculate its acceleration, so that will be simply equal to the resultant force on nucleus X divided by the mass of nucleus X. So the net force acting on this particle is only electric force. So we have written EQ over M. Now if we look at E is the same because electric field is uniform. Q is the same because the charge on particle is not changing. M is the same, so M is not changing. So it simply means that X has uniform acceleration. Acceleration is constant. It will not change with time. So simply we can draw the horizontal line, mean the acceleration of particle X is constant. So that's all what you need to do. If you draw this horizontal line, you will get 1 mark.